Good morning. We're going to talk about motion word problems today. And I'm going to do 6 out of the 14 for you. So that only leaves you 8 problems to do for this worksheet. All right, so the first problem I'm going to do is problem number 1 of this section. And number 1 says 2 buses start toward each other at the same time from towns 190 miles apart. One bus travels 40 miles an hour and the other 55 miles an hour. And how many hours will they meet? Well, the first thing I'm going to do is we talk about a bus, 2 buses. Bus 1 and bus 2. I'm going to make a table. Now this table, in general, rate times time equals distance. So when I make my table here, I need 3 sections. And the first section here is my rate section. And remember, rate times time is going to be equal to distance. All right. So it tells me that the first bus travels 40 miles per hour. The second bus is 55. Now, if you want to, you can always put the miles per hour down here. Don't put it inside the same box, because then you might think it's a variable, and we don't want that to be an issue for you. So, let's see. We don't know how long they took, but we know they both traveled for the same amount of time because they started at the same time. Start at the same time toward each other. So we're going to call time x for both of them. And remember, rate times time equals distance. So we're going to not worry about numbers for distance. We're going to say these multiply, giving you 40x for that expression and 55x for this expression. All right. So now I need to set up an equation. But before I do that, let's set up a little diagram. If you have, let's see, we said these were starting at the same time from towns 190 miles apart. So if bus 1 started here and bus 2 started here, bus 1 is going this way and it's going to travel for 40x miles, whatever that happens to be. And bus 2 starts this direction, travels this way until they meet at some point, and that's traveling at 55x miles. So in general, we're talking about adding these 2 distances because we said they were 190. The distance from here to here was 190 miles. So if we add that plus this, these 2 meet right there. They're like passing each other, and just as they meet, that's how their distance added together gives you the total distance between the 2 cities. This one traveled this far, this one traveled that far. Together, they're 190. So 40x plus 55x equals 190. And then we can go ahead and solve that. Adding these together is 95x equals 190. And then we're going to, let's see, divide by 95. X is 2. Now, The answer for X is not always the answer to the problem. Read the problem again to make sure what it's asking for. It says, in how many hours will they meet? X is the amount of time that they drove. They were driving at the same amount of time, and so X is 2 hours. And that is the amount of time it takes before they meet. All right, let's look at number 2 in our examples on this worksheet 2.6, chapter 2, part 6 of the old algebra book. And we said we were going to be doing number 2. All right, let's make a quick table again. In this one, we're talking about Sharon and George. Now George, I tended up that way. I'm going to make that a little better. I might not need it quite that long. All right. Rate, time, distance. I'm just going to use R for rate. Sharon swims towards the near shore. So here we have the buoy in the lake. All right. And Sharon is swimming in one direction, and George is swimming in the opposite direction. And when they are done, they are going to be 105 meters apart. All right, so Sharon is going to swim at 4.2 meters per second, and George is at 2.8. It goes on to say that the time is the same for both because they left at the same amount at the same time. It wasn't one left and then the other left. And then the distance is 4.2x, 2.8x. So one of them, George, was 2.8x, 4.2x was Sharon. And if you were to add these two distances together, because that's the same starting spot, 2.8x plus 4.2x would have to equal 105 meters. Well, if we continue to solve this equation, let's see, 4, 5, 6, 7x equals 105. And when I divide both sides by 7, x ends up, let's see, 15. So it turns out x is what they're looking for. In how many seconds will they be 105 meters apart? So 15 seconds. And that's all you have to do for number 2. Next one I'm going to do is number 7. I'm trying to do one of each of the types of problems that you can see on these. Number 7. In number 7, it says an aircraft carrier and a destroyer leave the same port at 6 a.m., sailing at in the same direction. So aircraft carrier and destroyer. All right. The aircraft carrier and destroyer, let's see. Aircraft carrier, the rate is going to be 16 miles per hour. And the destroyer averages 40 miles per hour. It goes on to say that sailing in the same direction leaves port at the same time. Leaves the same port. Leaves the same port. Aircraft carrier leaves the same port and sailing in the same direction. So they're both leaving at the same time. So time is still x. Oh boy. Oh good. Later I have some where x is not the same. All right, we'll talk about that. And we also have distance, 16x and 40x. So here's the situation. Here's the port. And they're going to leave at the same time. The aircraft carrier is really slow, going 16x miles. In the same time, the destroyer is going fast, 40x. And the distance between here and here is going to be 54 miles. So when the distance is 54 miles, that is when they want to know at what time will they be 54 miles apart. So the way you can set that up is this one, the long line minus the short line, equals how far apart they are. So 40x minus 16x equals 54. Now you could just as easily set this up as 16x plus 54 equals the full distance, 40x. But it turns out this is actually faster to solve. That's the only reason I'm setting it up this way. You absolutely could say 54 plus 16x equals 40x, and you would get the same end result here. Now, when I combine these two, I get 24x equals 54. And when I actually do this division out, when you divide by 24, x will equal 2 1/4 or 2.25. Now, it does ask not how many hours, which would be 2 1/4 hours. What it asks is at what time will they be 54 miles apart. Now they left at 6 a.m. So 2 1/4 hours later would be 8:15 a.m. That is what time they are 54 miles apart. Let's go to number 9 for our next problem. Let's see what number 9 has for us. It took a truck 5 hours, 30 minutes to cover the same distance that a car covered in 4 hours, 15 minutes. Find the rate of the car given that the car was driven 10 miles an hour faster than the truck. Well, we're talking about a truck and a car. All right. Now the rate. It tells you, given that the car was driving 10 faster than the truck, so if the truck is x, the car is x plus 10. We could have said that the car was x, then the truck would be x minus 10 because it's slower. The next part is the time. Now it tells us how much time each one drove. The truck drove for 5.5 hours, and the car drove for 4 1/4 hours. Now, I may run out of room in my box here for the last part. I may have to extend that a little bit. In fact, I think I'll extend it now before I even finish writing. because it'll just make this work a little bit easier if we have extended that first. Distance. In this case, when I multiply 5.5x, and when I multiply here, I get 4.225x plus multiplying times 10, 42.5. It said specifically that they went the same distance. So I can set up my equation setting the two distances equal. 5.5x equals 4.25x plus 42.5. Now this doesn't take all that much time to solve. I'm going to subtract 4.25x from both sides. So that gives me 1.25x equals 42.5. And then when I divide both sides by 1.25, x ends up as 34. Now, what does x represent here? X represents how fast the truck was going. The question was, how fast is the car going? Well, if the truck is going 34, the car is going 34 plus 10, or the car drove 44 miles per hour. Notice how I've been putting the units in for all of these as we go along. That's important. You gotta do it. If I were giving you guys tests on this stuff, I would be requiring units, and I would take points off if you didn't have the unit. All right. Let's go to the next one here. And I'll have to take that and find out who it is before I say. And where is the phone?